already down to our last sample problem number 5. A ball is thrown from A, this point. If it is required to clear the wall at B, determine the minimum magnitude of its initial velocity, VA. So, natay angle 30 degrees. We have Y 3 and then ang Y final at this point is 8 feet. And then distance of the initial position to its final is equal to 12 feet. So if you notice sa aning problem, ang iyang solution is, iyang origin is dirigikan. So ako, I would like to make here the origin. Just like in a previous example, ang origin sa solution is here and then I solve with the origin here. So opposite yapon diri. So diri na pod ako ang origin. Okay, so this is the drawing from the problem. So since this is feet, this is English units, our gravitational acceleration due to gravity is equal to 32.2 foot per second squared. So we have the x, we have the y, but we don't have the acceleration. So this is the a, or the velocity. So this is a, therefore our initial velocity this is the v sub a. So we namatay duha ka values sa x ug sa y, and then therefore we can have two equations to solve for the velocity. So first one, we use the horizontal. From the horizontal component, we have the final position is equal to the initial position plus the initial velocity, horizontal component, times the time. So our final position from this to this point is equal to 12 foot. 12 is equal to initial position, that is just 0, plus we don't know v sub a, and then the x, VIX, so this is cosine of the 30 degrees times the time. Since this has two unknowns, therefore we need to have two equations to solve for two unknowns. So simplifying further, we have 12 is equal to VA cosine 30 t. So this is our first equation. Or I would like to write this into VA times t. We have VA cosine 30 times t equals to 12. V sub a, t is equal to 12 over cosine 30. Now, we're using the vertical component of the projectile. We have y, the final position sa vertical, and then is equal to the initial position plus the initial velocity, the y or the vertical component, times the time, minus 1/2 of the gravity times the square of the time. So ato ang y, since akong giingon is diri matang origin, so diri the final position is, we can diri paingon diri is 8 foot or 8 feet. So that is 8 equals to initial. So ang iyang initial position along the y is from this point to here is 3 feet. Plus, we don't know the initial velocity, VA sine 30 times the time minus 1/2 the gravitational acceleration is 32.2 t squared. So if you notice lagi po ni VA, the V sub a times t, then we can use this equation. This is equation 1. Simplifying further, 8 minus 3, we have here 8 minus 3 is equal to sine 30 times VA t minus, this becomes 32.2 divided by 2, that is 16.1 t squared. This is VAT. We have here VA times t. 8 minus 3 is 5 equals to sine 30 times 12 over cosine 30 minus 16.1 t squared. So simplifying, we know that sine 30 divided by cosine 30 is just tangent 30. 5 equals to 12 tangent 30 minus 16.1 t squared. So putting all the unknowns on the left hand side and all the constants on the right, we have 16.1 t squared is equal to 12 tan 30 minus 5. So we have here 16.1 t squared. Then 12 tangent 30 minus 5, that is equal to 1.9282 divided by 16.1 divided by 16.1. T squared is equal to 0.119764178. Extracting into square root, we can solve for the time t equals to 0.3461 seconds. So we are not done yet. Since we were asked about the initial velocity, we can use this equation to solve for the initial velocity. So we have here v sub a, initial velocity times the time is equal to 12 over cosine 30. Initial velocity is equal to 12 over t cosine 30 equals to 12 over the time is 0.3461 cosine 30. So our initial velocity at A is 12 over 0.3461 cosine of 30 degrees. That is 40.036 foot per seconds.